Hello and thank you for watching my video. My name is Astrid Krasniqi. I'm CCNA and CCNP certified instructor. On this video we are covering CCNA semester 2, routing and switching essentials, and this is chapter 3. This is section 3.2 VLAN implementation. Upon completion of this section, you should be able to configure a switch port to be assigned to VLAN based on the requirements, configure trunk port on a LAN switch, and configure dynamic trunking protocol or DTP. How many VLANs can you configure on the switch? Well, we have normal range and we have extended range. On normal range are VLANs from 1 to 1005. The range 1002, 1003, 1004, 1005 is reserved for token ring and FTTI VLANs. They are reserved, but they are not supported, but they are there. 1 and 1002 to 1005 are automatically created and cannot be removed. The normal range is stored in vlan.dat, which is in flash memory, right? So it's stored in a file called vlan.dat, which is in flash memory. So that's why when you delete, you say delete vlan.dat, it deletes from flash. Or you can say show flash to see if you have a VLAN database there. Then we have extended range. The extended range are from 1006 up to 4094. This extended range are designed for service providers, because there was not enough VLANs available, so the service provider required more. Then they created an extended range. There has a fewer options than a normal range VLANs, and this is stored on running configuration file. Now, service provider, even with this extended range, they said that it's not enough, so they do create, for example, private VLANs to satisfy more customers that they have and so on. But that private VLAN we're going to talk in the next video. So for you to remember, we have a normal range. Normal range is stored in vlan.dat flash memory, and it's from 1 to 1005. 1, 1002, 1003, 1004, and 1005 are automatically created, and you cannot delete them. Extended VLANs, extended range, are stored in the running configuration file. Cisco Catalyst 2960 switch supports 255 normal and extended range VLANs. Type of VLANs. First, we have a default VLAN. Default VLAN, it's VLAN1 by default. Then we have a native VLAN, VLAN1 again, it's by default. This is native VLAN, it's used for untagged traffic. Later we're going to talk about it. User VLANs, each IP subnet is in separate VLANs. For example, earlier we created VLAN 10, name sales, VLAN 20, maybe name IT or whatever. Those are user VLANs. Then we have a management VLAN. VLAN to connect to infrastructure devices such as switches. So all the switches you put on different VLAN, for example, called management VLAN. That management VLAN is only to access the switches. So layer 2 switches, for example, as well. For example, you would put them on VLAN 99. Then we have a voice VLAN. VLAN used to connect IP phones. This is important because maybe we want to get them better quality of service for the voice traffic. Then we have a guest VLAN. This is to connect guests and others who do not have access to internal resources, perhaps internet access only. And then we have a garbage VLAN, or maybe a better word would be unused VLANs. This will you put all unused ports or the ones that are not yet configured to VLAN unused VLAN or garbage VLAN as they call it here. But by default, all ports are on VLAN1. So Cisco does recommend you to remove all the ports from VLAN1 and put them on unused VLAN. You create VLAN, whatever you want to create, a VLAN 55, 500, or whatever you want to create it, and put them in there. By default, all traffic is carried across VLAN1. By default, all the ports are on VLAN1. So VLAN1 is the default VLAN. It has all user traffic, all the ports are there. It's native VLAN, no trunking encapsulation, even if configured as trunk. Coming, we'll see it, what is a native VLAN very soon. And all layer 2 control traffic. Example, we have a TTP, VTP, spanning tree protocols, BPDUs, PAGP, LACP, and all that, and CDP and so on. They're all being carried on VLAN1. So for that reason, Cisco does recommend that you remove all the ports from VLAN1 and you put them on different VLANs. Unused or used, whatever, just remove them from VLAN1. Because VLAN1 already has all this traffic to communicate, to send it through. It's control traffic. So That's why we want to leave it empty from our user ports. This, I don't know, do you like know them? Most of these you haven't covered them. Spanning tree is CCNA 3, PAC-P and LACP as well, CCNA 3, chapter 3. DTP, dynamic trunking protocol, we're going to learn that today on this video. And then CDP, Cisco Discovery Protocol. This is a layer 2 information, like what you do, like tells the neighbor what the capabilities is and the IP address. Quite good, useful stuff like you get with the CDP. Anyway, Cisco does recommend that you turn off the CDP. Default VLAN, so VLAN 1, it cannot be deleted, so you remember that the VLAN 1 can't be deleted. Security best practices, avoid using VLAN 1 for all VLANs other than control traffic, which must be on VLAN 1. In other words, create additional VLANs. So when we do show VLAN, we should see all our ports that belong to VLAN 1. User or data VLANs, these are the VLANs used for different user VLANs or subnets. So we go and create them for user data traffic. What about the ports not in red or blue, like these two ports, for example? Well, those blue ports are still, because if you have not moved them to any VLAN, they're going to remain on VLAN 1. And you can, but later on, we're going to look at how to change them or give them to a voice over IP VLAN. Creating static user VLAN. This is the same slide as you saw it on the first video, if you've been watching the order 3.1. So by default, we go and configure the VLAN. Statically, we go and configure VLAN. So global configuration, VLAN 10, whatever number you want to type. So VLAN 10 on this case. Give a name, and it's optional. Then you access the individual port, like for example, interface fast Ethernet 02, and tell that it's going to be an access port. Command is switch port mode access. We tell in here that it's going to be an end device connected to it and not another switch. So we don't need a trunk port. They can either be an access port or trunk port. So we tell an access port. And then we say what VLANs to access. So switch port access VLAN 10. So now we have moved VLAN, port 2 to VLAN 10. If you assign an interface to VLAN, so say that we don't do any of this, yeah, we forget to do this, right? Any of this. And we go directly we go to this interface and we say, okay, access VLAN 10. The switch is going to create a VLAN for you. Now we can create dynamic VLANs, can be configured using a special server called the VLAN Membership Policy Server, VMPS, but is not covered on CCNA routing and switching exam. Instead of doing one by one, we go to the individual port. We can do it as a range, yeah. So we can access interface range fast Ethernet 01-10. So we do the whole range there, and then say an access port, switch port mode access, switch port access VLAN 10. Then we do go to the gigabit Ethernet port, and we do the same thing. Then we do the VLAN 20. So VLAN 20, we give it sales name here, and then we add them all the ports on the sales VLAN. Okay. Then when we want to configure, confirm, we say show VLAN. We can see the ports 1 till 1 till 10, and then G01, it's on VLAN 10. Port 13 to 22, and G102, it's on VLAN 20. Port 11, 12, 23, and 24, these two ports here. This one, sorry, is red. This one is still on VLAN 1. Show interface FA01. 0/1 switch port is a great command. This is going to show you quite a lot of information that we're going to even visit this command when we talk about trunking. But at the moment, it's telling us that it's accessing VLAN 10 or the HR. And we can see that the administrative mode here, this is very important. The administrative mode, it's a static access, whatever we have configured it. Port 01, because there's nothing connected to it, at the moment is down. The administrative operational mode is down, right? So there's nothing connected to it, but it's on the VLAN 10. So show VLAN brief, this is going to show us the VLANs, same as the other command, but in here what I want you to pay attention to is these four as well, yeah? So these 1002, 3, 4, and 5, they are on by default. By default, they are there, active, but as you can see, it says unsupported. So we don't support them, but they're there. For some reason, we can't remove them, we can't delete them or anything like that. They just have to be there. As well as VLAN 1. VLAN 1 is a default, but this is active, and it is supported. And again, this one we can't delete it, we can't rename it, anything like that. Management VLAN is when a VLAN, for example, you create a VLAN and you can like SSH to the switch and give an IP address and manage the switch. And default is VLAN 1. But we really should go and change it from VLAN 1, and like we said, change it to different VLAN. You create VLAN 99, for example, and then give an IP address in that VLAN. Anyway, here we are doing in VLAN 1. Interface VLAN to create s.svi. Yeah, this is SVI. SVI. Switch virtual interface. You do interface VLAN 1. And in there we give a description. You're going to get points for that in your exam. And you give an IP address. So IP address 192.168.10.254, and then subnet mask, and then we say no shutdown. So we have to do no shutdown. Even though the switch ports, the physical ports, are not shut down by default, the virtual port is not. So we have to do that. The switch can be managed via HTTP, Telnet, SSH, or SNMP. Try not to use any a clear text protocol like HTTP. You would use HTTPS better, and you would use SSH or SNMP v3, for example, to manage the VLAN. A manager VLAN is used to manage the infrastructure devices, including switches, routers, access point, and others. Security best practice is to change the management VLAN to other VLAN other than VLAN 1. So instead of using VLAN 1, change, I don't know, VLAN 99 is very common. We will discuss this later because we need to route to the management VLAN. Voice VLANs, voice over IP traffic requires assured bandwidth to ensure voice quality, transmission priority over other types of network traffic, ability to be routed around the congested area of the network, and delays of less than 150 milliseconds across the network. Security best practice is that voice traffic must be placed in a separate VLAN, so we create a different VLAN for voice traffic. Now, when we connect two switches together, this is called, they connect with a cable, crossover cable, hopefully, you put in, and that's going to be trunk. A VLAN trunk carries more than one VLAN. So a trunk is like you grab all the VLANs you've got on the switch, and if you want to send any information to other VLANs, same VLANs on the other switch, then they're going to go through the trunk port. A VLAN trunk is usually established between switches, so same VLAN devices can communicate even if physically connected to a different switch. A VLAN trunk is not associated to any VLANs, neither is a trunk port used to establish the trunk link. So Cisco iOS supports 802.1q. Trunky protocol is very popular. And there's another one that actually Cisco supports its own trunky protocol, which is called ISL, Inter-Switch Link. But now they kind of like, this is deprecated, this protocol. They favor 802.1q because it uses the tagging, which you're going to see very soon, while ISL does encapsulate the whole frame, which creates extra bytes, so no good. VLAN trunking, so for example, all these VLANs that we have, VLAN 1, 10, 20, 100, 155, 199, garbage, native VLAN 200, they're going to go through this trunk port. So the trunk does not belong to just one VLAN, but it carries all the VLANs, including the default, as well as any other VLANs that we have created. We can control, for example, in this trunk, we can say, okay, well, we do want to allow all of these, apart from we don't want any VLAN 20, so we can stop some VLANs coming on our trunk port. We're going to see it very soon. Tagging, frame tagging is a process of adding a VLAN identification header to the frame. It is used to properly transmit multiple VLAN frames throughout a network link. Switches tag frames to identify the VLAN to that they belong. Different tagging protocol 802.1q is popular. So we have different tagging, ISL. I'm telling you about ISL because there's one command, if it does support two protocols, if it does support 802.1q, and ISL, you need to type one command. It's kind of annoying. The protocol defines the structure of the tagging header added to the frame. Switches add VLAN tag to the frame before placing them into the trunk link, and remove the tags before forwarding frames through the non-trunk port. So as a PC sends a frame to the switch, the PC doesn't know that it's part of the VLAN, it just sends it empty. If the switch has to take that frame and send it to another switch to go to the same VLAN but in different switch, then the switch will tag it. I will say, okay, well, this belongs to VLAN 10, add that information, send it to the second switch. Second switch, before it sends it to the PC that's on VLAN 10, it will remove that tag. When properly tagged, the frame can traverse any number of switches via trunk links and still be forwarded within the correct VLAN at the destination. So this is the frame. For example, remember that we have a destination MAC address, source MAC address, type length, so is the IP, and so on, data, and frame check sequence. Now that the 802.1q will put information between the source MAC address and type. In there, between those two, it will add a tag. And that tag is made out of this field, so we're going to see them. So the tag is added by the switch before it goes over the trunk link. So for example, if say PCA, so if I can just write here, say it belongs to VLAN 10, and this PC belongs to VLAN 10 as well, right? So when this CPC sends a broadcast message, it will go to the port, to the switch. Switch will identify this as a broadcast message, and it knows that it's going to send it out of this port. It will add the tag here. As it's leaving the switch, it will add the tag. This switch will get the tag, receive, okay, well, it's a VLAN 10, so I'm going to forward it to the correct port. It will remove that tag. So if the switch has to send, for example, if there's a PC connected here, yeah, say another PC is connected here, and it belongs to VLAN 10, and say we don't have that connection here. We don't have this connection. So this PC, when it talks to this PC, the switch is not going to tag that message. Because, okay, yeah, tag as it's coming in, go in RAM, do the CRC check, remove the tag. It just knows automatically it's on VLAN 10, and it's going to send it to the correct port. So what I'm saying is you're not going to be able to see it anyway. But here you will be able to see the tag as well, because as it's traveling through to another switch, if you capture any data here, you will see it. So what this tag is made out of, first we have 2 bytes. This will identify that, for example, it's Ethernet frame. Then we have a priority. In here we can add priority for example, for voice VLANs. We can identify here, give them better priority. Here enables token ring, which we don't have, frames to be carried across Ethernet networks. And then the last bit is actually your VLAN, the VLAN ID. VLAN identification number that supports up to 4096 VLAN IDs. The native VLANs, they don't get tagged. So frame that belongs to the native VLANs are not tagged. Frame received untagged remain untagged and are placed in the native VLAN when forwarded. If there are no ports associated to the native VLAN and no other trunk links, untagged frames is dropped. In Cisco switches, the default native VLAN is VLAN 1. So let's have a look at this. If I go back here to this, let me just try and clear a little bit. Yeah. So okay, like we had it earlier. So imagine that this is on VLAN 10, this PC, and this PC is on VLAN 10 as well, right? So if this PC sends a message, like say, imagine broadcast, yeah? As it's coming into the switch will identify that it's VLAN 10. Yes, I need to tag it. And it will tag it as it's leaving the port. So it's going to go here, tagged. And this switch will identify, oh, okay, it's a VLAN 10. So before I send it here, first I'll remove the tag and then send it forward. Okay. Now, imagine that there's another PC here, right? So this PC, it's on VLAN 11, right? So, and I got a PC here, it's on VLAN 11 as well, right? Now, VLAN 11. Now, with native VLAN, you can pick one VLAN that's not going to get that tag. So by default, it's VLAN 1. But say that we pick in VLAN 11, it's our native VLAN. So as this as this PC sends a message to the switch will look and says, oh, okay, well, it's common VLAN 11, and my VLAN 11, it's native, so I don't need to tag it. So it's going to send it untagged to this switch. When this switch sees something untagged, says, okay, well, that's VLAN 11, so I'm going to send it out of this port. For this reason, the native VLAN has to match, right, on both switches. So for example, if in this switch, say this is S1, yeah, and this is S2. Say in S1, the native VLAN is 10. That's our native VLAN. And native VLAN for in S2 is 11. That's unmatched. These native VLANs that don't match, well, you're going to get lots of errors, like a syslog messages on both switches. the native VLAN mismatch, native VLAN mismatch, and so on. But anyway, this is the problem. If VLAN 10, PC on VLAN 10 sends a message, yeah, so it takes a message, sends it to S1. S1 says, okay, well, this is in my native VLAN. Since it's in my native VLAN, I'm not going to tag it. So it sends it to S2. But S2 looks at that and says, okay, well, it hasn't got a tag. And since it hasn't got a tag, my native VLAN is VLAN 11. So I'm going to send it here. That's a problem, right? So VLAN hopping from VLAN 10, we become VLAN 11. So that's why the two switches, they have to match the native VLAN. By default is VLAN 1. So native VLAN for devices that do not support tagging, all trunks must have a native VLAN. A native VLAN must be the same on both switches, on both ends. Can be modified to be a VLAN other than VLAN 1 and should not be used for user VLAN or management VLANs. Control traffic, CDP, VTP, PACP, DTP still transmitted over VLAN 1, even if you change the native VLAN. If native VLAN is other than VLAN 1, the control traffic on VLAN 1 is sent tagged. It is fine to leave VLAN 1 as a native VLAN, but should only carry control traffic and not user or management traffic. Controlling broadcast domain with VLANs. So VLANs can be used to limit the reach of the broadcast frames. A VLAN is a broadcast domain on its own. So a broadcast frame sent by device in specific VLAN is forwarded within VLAN only. VLAN help control the reach of broadcast frames and they impact in the network. Unicast and multicast frames are forwarded within the originating VLAN. So for example here, between the two switches, in switch 1 we have VLAN 10, 20, and switch 2 the same, we have created, you saw that early. If we do show VLAN brief, we see, and the ports as well, that they've gone to VLAN 10, and ports that have gone to VLAN 20, or we have configured it. But as well as, we have port FA01. FA01 should not be an access port. What we want, this port is the trunk port. So it's going to carry all the VLANs from one switch to another switch. By default now, if it's an access port, it will just carry the VLAN 10 information. Same for VLAN 1. So what, switch 2. So what we want to do is this port FA01 to make it a trunk port. So the command, you go to access that individual port FA01 and say no switch port access VLAN 10. So we remove it from VLAN 10 and we say switch port trunk encapsulation.1q. Now this command, it's only necessary and it's only valid if the switch supports two protocols. If it supports 802, sorry for my writing here, 802.1q, that's one that we actually using with tagging and so on. But I told you there's another protocol, there's a Cisco proprietary protocol called ISL, right? So if the switch supports both, it will go for ISL. But anyway, we have to say that we do not want ISL, we want 802.1q, and you actually have to spell it, .1q. Switch port trunk encapsulation 8.1q. That's the first command. And then we say, okay, only needed on switches that support ISL, that's what I'm saying. And then we say switch port mode trunk, right? Because if we say switch port mode trunk and we don't actually specify what encapsulation it is, we will get an error saying to us, okay, well, command rejected. It will be in the capital letter and it will say, okay, can't do it because it's in auto. I don't know if it's ISL or .1q, so I can't be trunk. So first you need to tell that encapsulation is .1q. On the switches that do not support, all you need to do is switch port mode trunk. That's it. But if you do this command and you get an error, yeah, you have to type this command. I tell my students, always type this. Anyway, even if it doesn't support, type it, just in case. And then if it doesn't work, it will give you an error, but at least you covered your back. Because if you type this and you don't see the command rejected, you might miss you actually didn't do the configuration. When we do show VLANs now, the port FA01 on both switches, it will not be there. So show VLANs, port FA01 doesn't appear. So here we don't know the 01. What's wrong with 01? Is it part of some VLAN or is it trunking? So there's no trunking information that we see here, but we can suspect that it's trunking. For example, the reason why I'm telling you that, because if I go and remove this 20, VLAN 20, say no VLAN 20, right? You go to global configuration mode and you say no VLAN 20. All these ports, they will disappear. They won't see any of these. Now none of them is trunking, but there's just no VLAN, so they are kind of like a zombies. They don't go back to VLAN 1 by default, so you have to go and configure them to put them to one VLAN, the working VLAN. So do not delete the VLANs without actually removing the ports from that VLAN first. So for example, if we want to delete VLAN 20, we go and move these ports to another VLAN, I don't know, 10 or some other VLAN, and then we say delete the VLAN by saying no VLAN 20. So the command, gray command, show interface trunk, this is going to show you what interfaces are trunking. So the first thing we see here is that port 01 is trunking. Mode is on because automatically, statically we configured it to be a trunk. So it didn't negotiate or anything, statically configured to be trunk. And encapsulation that it's using is 802.1q. In this section we could have ISL as well, but at this point we have 802.1q. ISL does not support trunk, native VLAN. So if you're using ISL, there's no native VLAN. Status of this port is trunking, and the native VLAN is VLAN 1. We haven't changed that. We can see that this port is allowing all the VLANs from 1 to 4094 are allowed, and the VLANs allowed and active is 1, 10, 20. We have 3 VLANs, and VLANs in spanning tree forwarding state and not pruned, nothing. We're going to talk about that later. Configure the native VLAN. So if I go to the interface FA01, that's my interface is trunking, and the command is to change the native VLAN, switch port trunk. So first command was switch port mode trunk to make a trunk port, and now all the commands say, okay, start with switch port trunk, native VLAN 200 now. And you're going to get these messages. This syslog messages says, okay, native VLAN mismatch discovered. On fast Ethernet, our port is 200, fast Ethernet 200, fast Ethernet, sorry, 0/1, our VLAN is 200. With a neighbor, switch 2, which is fast Ethernet 01, and their VLAN is 1. So in brackets, it's telling us what is the our VLAN and their VLAN. So same will be on the switch 2 as well. But once you go on to configure it, ignore those messages and just go and configure it. Switch port trunk, native VLAN 200. Now the native VLAN does match, so it's fine. VLAN 200 native VLAN does not need to be created on either of the switch, but it must match on both ends of the trunk. Controlled data like CDP, Cisco Discovery Messages, or spanning tree protocol, others, is still sent across VLAN 1, but now it's being tagged. So now when we done everything, all configure the native VLAN to match on both of them, all the switches, they're gonna stop sending us all these syslog messages. Now we can think about, okay, well, how about limiting some of the VLAN trunks, VLAN to go in our trunk? So maybe we don't want to allow everything, yeah? So that's kind of like we want to stop maybe some VLANs going through the trunk. The command again, you go to the interface, single interface, and the command is switch port trunk again, starts with. If you can't remember, just start switch port trunk, space, question mark, see what commands are there. Allowed VLAN, so we're only allowing 10, 20, and 200, right? So on the, as they're coming in on switch 1, for example, as they're coming in here, as they come in this side, we only allowing 10, 20, and 200, nothing else. And then go to switch 2, we do it again, switch port trunk allowed VLAN 10, 20, and 200. No spaces between VLANs. If the native VLAN 200 is not on the list, that's not a problem. The trunk will not allow any data traffic for the native VLAN. Now, here, for example, even though we're saying the VLAN 1 is not in the list, but does that mean that we don't have any more control traffic? No. Control traffic is still going to go through, like CDPs and STPs and so on. When we do show interface trunk, you'll see the VLAN allowed on the trunk 10, 20, and 200, and the same on the other switch, on the switch 2. If we do show running config, we can see the fast Ethernet 01, the port is a native VLAN 200, sorry. What VLANs are we allowing? At the mode that is trunk, and we can see port 2, 3, and the rest of the ports are in VLAN 10. Now, DTP, it's a Cisco proprietary protocol, great protocol. It stands for Dynamic Trunking Protocol, and these switch ports can be manually configured to form the trunk, or switch port can also be configured to negotiate and establish a trunk link with the connected peer. The dynamic trunking protocol manages this trunking negotiation. DTP, again, is a Cisco proprietary protocol and is enabled by default in Catalyst 2960s and 3560 switches. If the port on the neighboring switch is configured in trunk mode that supports DTP, it will manage the negotiation. The default DTP configuration on Catalyst 2960 and 3560 is dynamic auto. We'll see the modes very soon, but the only reason why they're talking about these two switches is because it's Cisco routing and switching exam concentrate only on those two switches, 2960 and 3560. And the mode they're talking about is dynamic auto. You're gonna see it very soon. So switch Ethernet ports can be an access port. This is a non-trunking port used to connect the end devices. Can be on the trunking mode, trunking port to carry VLAN information to other switches. By default, layer 2 switch ports wants to trunk. So if we had, say, configure it as an access port, so switch port mode access forces the link into an access port. So saying, okay, well, I know this port and this port, it's going to be PCs on it. Yeah, go and configure it to be an access port. It will never become a trunk, and it's used to connect to host, servers, printers, and so on. So DTP is a Cisco proprietary, again, protocol that negotiates trunking parameters between the switches, operates on the point-to-point basis only between network devices. It's designed to make interconnecting switches with a VLAN easier. DTP is only available on Cisco switches and not supported by any other vendors. For DTP trunking modes, so we have switch port mode. We can say an access port, and this is, if we say an access port, we are saying end device is going to be connected to it, and unconditionally we are making an access port, so unconditional access port. Or we can say a trunk port, so these are like static configuration, trunk unconditionally. Or we can leave it to dynamic. Dynamic is going to negotiate. Is either going to be, let's see the commands, either going to be an auto, so it's either going to be an auto or desirable. Auto says, okay, well, I'm not going to start negotiation. I'm not going to want to be trunk. But if you want to be trunk, then fine. I'm not going to stop it. Desirable is going to desire to be trunk. So it's going to always ask the other side, can we become trunk? Can we become trunk? If the other side is in auto, they will become trunk. The problem is that if both sides are in auto, then nobody's starting the communication, can we become trunk? So they're going to be in an access port. So on default mode is locked into trunking mode, switchboard mode trunk. Dynamic desirable mode, switchboard mode dynamic desirable, and the other two switches, 2950 and 3550. And an auto port, dynamic auto, switchboard mode dynamic auto. Or you can disable the negotiation of trunking, so turns off the DTP by saying switchboard no negotiate. So what you can say, for example, switchboard mode trunk, and then you can say switchboard no negotiate. So when we do the command show interface fast Ethernet 021 switchboard, we can see the administrative mode is dynamic auto. Okay, this doesn't match with this, so this is FA01, this is 21. But anyway, imagine that it's supposed to 01, yeah? Administrative mode is dynamic auto. So ports on 2960 and 3560s by default are set to dynamic auto. Dynamic auto does not trunk in both sides are set to dynamic auto. So if you say dynamic auto on this side and dynamic auto on this side, no one starts the trunking negotiation. And since there's nobody starting the trunking negotiation, they're going to be in access port, right? So it's going to think, okay, well, there's another PC on the other side. So how the port was configured, how the port is operating. These are very, very useful commands. Show interface, fast Ethernet, whatever you want, and then switch port at the end. It's going to tell you what is the configuration and what is it operating at the time. Negotiation of trunking on. Okay, so these are the ports. So we have an access port that puts the interface to permanent non-trunking mode and negotiates to convert the link into a non-trunking link. The interface becomes a non-trunking interface even if the neighbor interface does agree to the change. So for example, does not agree to the change. For example, if an access port is on this side, it doesn't matter what's the other side. It's a trunk, dynamic desirable, dynamic auto, doesn't matter. It's still going to be an access port. Or we can say a trunk port. trunk port will always be a trunk. It's like permanently you are setting it to be a trunk port. No negotiate puts the interface into permanently trunking mode, but prevents the internet interface from generating DTP frames. You must configure the neighboring interface manually as a trunk interface to establish a trunk link. Use this mode when connected to a device that does not support DTP. So for example, say non-Cisco device you connect, you can't, the other ones they don't even understand that DTP, so you can stop it. Dynamic disable makes the interface actively attempt to convert the link to a trunk link. The interface becomes a trunk interface if the neighboring interface is set to trunk, disable, or auto mode, not an access port. Dynamic auto makes the interface willing to convert the link to a trunk link. The interface becomes a trunk interface if the neighboring interface is set to trunk or disable mode. This is the default mode for all Ethernet interfaces on the Cisco iOS switch. Trunking modes must be compatible, so switchboard mode trunk, and the other side you have to say switchboard mode trunk. So don't say switchboard mode access, because obviously it's not going to work. Both ports configured with switchboard mode trunk, effectively forcing both ports to stay in the trunking mode. Or you can say switchboard mode dynamic auto. On switchboard mode dynamic auto on this side as well. As you can see, both sides are dynamic auto. Nobody's negotiating the traffic, and this is going to end up being an access port. The link is not a trunk. Both ports configured with switchboard mode dynamic auto results in an inactive trunk link. So switchboard mode trunk, this is DTP mode on, forces the link into permanent trunking even if the neighbor doesn't agree, enables DTP and exchanges the DTP frames, will trunk if remote is configured with on, if the other side is on, switchboard mode trunk. If the other side is configured with switchboard mode dynamic disable or switchboard mode dynamic auto, still will trunk with all these three. Will not trunk if the other side is non-negotiate and is set to switchboard mode access. Dynamic disable, switchboard mode dynamic disable causes the port to proactively attempt to become a trunk, enables DTP exchange messages, and then it will trunk if the other side is set to on, switchboard mode trunk. Is it disable mode on the other side, or if it's an auto port in the other side, dynamic auto. It will not trunk if it's again non-negotiate or access. If you set the port to mode to dynamic auto, this causes the port to passively be willing to convert to trunk, enables DTP and exchange DTP frames. Will trunk if remote configured with on, switchboard mode trunk, if remote configured with switchboard mode dynamic disable, but it will not trunk if the other side is configured again with auto, non-negotiate, and an access port. Not trunk in there. DTP disabled, switchboard non-negotiate, forces the port to permanently trunk, disables DTP and does not exchange DTP frames. Used to trunk with the different vendors' switches. Thank you very much for watching this section 3.2 VLAN implementation, and please have a look at other videos, and please don't forget to subscribe. Next video is 3.3 VLAN security and design. Bye bye.